So in section 3.3, we had a polynomial, like the very last video. We had a polynomial and we found, because they gave us a 0 and then we had a quadratic and we factored it, and we found that the polynomial could be written as x minus 3, x plus 2 times 2x minus 1. And so we were able to get that polynomial in terms of these binomial factors. And then we could find the zeros, and that was great, and life was just wonderful. Okay, the problem is they don't always give us zero. So we got to do that because we were doing the factor theorem, and they gave us, one of the zeros. But they're not always going to give us that. Sometimes we have to find them. We're going to get a polynomial. We're going to get a polynomial in a minute here. And we have to find all the zeros, okay? We have to find when does that polynomial equal 0? And we don't know, okay? So we don't want to have to just guess all kinds of numbers. So there's some helps that we have. So say you have a polynomial. And so you've seen this before. Something like that for a polynomial. And we're going to say that that polynomial has integer coefficients. So in the past, we've said, we can just have them be real numbers. But now for this theorem, it's called the rational zero theorem. We have to have integer coefficients. So just a little bit about theorems. So in this chapter, when we're doing these sections, they all kind of work together. They relate to each other, but there are a lot of theorems. So I recommend you get a nice note page or a piece of paper where you could write these theorems down so you can keep track of them. Otherwise, it might get complicated. You might not remember everything. So, because there's a lot of theorems. So here's another one. It's called the rational zero theorem, or sometimes I'll call it the rational roots theorem. Okay. So you have a polynomial, some polynomial, and it has integer coefficients. Okay. We're going to say that P is a factor of a sub 0. So remember, this is the constant. It's the last term. These polynomials are in standard form. And so P represents just a factor of that. So let's say a sub 0 is equal to 12. Then P would be all the factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, I had to pick a long one, plus or minus 6. Those are all the factors of 12, okay? Now I have to put plus or minus because negative numbers are factors of 12. These could be integers, okay? So any of those are factors. They're going to be factors or integers, and it could be positive or negative. But 1, 2, 3, 4. Oh, I left out 12, didn't I? Whoopsies. 1, 2, 3, 4, 6, and 12 are all factors of 12. Okay. Q is going to be the is a factor of a sub n, the leading coefficient. So say a sub n is 3. Well, then Q is going to be plus or minus 1 or plus or minus 3. Okay? All right. We just traditionally use the plus or minus. Okay. So you're going to look at the constant at the end, and you're going to think about the factors of that constant. You're going to look at the coefficient, the leading coefficient, and you're going to think about the factors of the leading coefficient. Okay, so the rational zero theorem says that possible rational zeros have to be in the form P over Q. Okay? So I didn't pick a very good example because there are a ton of them here. But you think of all the factors of P. So you've got the plus or minus 1, the plus or minus 2, the plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And then it has to be over plus or minus 1, plus or minus 3. So if you just put it over 1, that would be all of these. So all of those numbers are possible rational zeros. They could be a 0. We don't know that they are a 0, but they could be. But also, you have to think about all those numbers over 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 3/3, which is 1, and we already have that, so we don't need it again. Plus or minus 4/3, plus or minus 6/3, that's 2, and we already have that. We don't need that one again. See, we already had the 2. Okay, and plus or minus 12/3, which is 4, and we already have that. So you're adding these possible rational zeros, okay, plus all of them over 1. Okay, that's the idea. So it could be, like I said, I picked 12 that had a lot of factors, so that was my bad. Okay. So it says list all the possible rational zeros. Okay, so go to the constant, that's going to be your P. So factors of 4. Plus or minus 1, plus or minus 2, plus or minus 4. Those are the factors of 4, okay? You can put commas between these. A lot of times they put commas, which I probably should have done, but putting my commas in the wrong place. Anyway, Q, those are going to be factors of -1, which is plus or minus 1, okay? Well, that makes it a little bit easier, so I don't have as many choices. So P over Q is plus or minus 1, 1 over 1, plus or minus 2, 2 over 1, plus or minus 4. Okay, so I have 6 choices, right? Those are they. Those are the possible rational zeros. So, like if I'm guessing numbers, I'm not going to guess 3 because it's not one of the possible rational zeros. By a rational zero, we mean it has to be either a fraction of integers or it could be an integer itself. Okay, sorry about that. I was missing the polynomial one. Okay, so now we have another example. List all the possible rational zeros of, and then here they give us this one. So I don't want to have to just guess numbers. There's a lot of integers out there to guess, right? And then if I include the fractions, well, there's an infinite number, right? Okay, so I want to narrow things down so I know what numbers to try. So P, it's going to be the factors of 2, which is going to be plus or minus 1 and plus or minus 2. Q is 15. Well, the factors of 15. Plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Those are all the factors. Okay, so now what are the possible rational, so not the irrational numbers, not like the square root of 2 or something, but the possible rational zeros, what will they be? It's going to be P over Q. So you have to take each of these factors in P over each of the factors in Q. So it's 1 over 1. I'll write it out so you can see it. It's going to be 1 over 3, plus or minus. They all get a plus or minus. 1 over 5, 1 over 15. Okay, so it's all those. Then I have to take the 2 over all of them. So plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 2 over 5, and plus or minus 2 over 15. Okay, so there's a lot of them. And this is one way you could write it out. What we normally do is if it simplifies, we would simplify it. So we would list it this way, plus or minus 1, plus or minus 1/3, plus or minus 1/5, plus or minus 1/15. Those commas are bugging me. Plus or minus 2, plus or minus 2/3, plus or minus 2/5, and plus or minus 2/15. So then when I want to say, hey, what do I think it might be a 0? Well, these are my choices for the rational ones. This is the answer. This is a list of all the possible rational ones. So I'm not going to try 4/7. because it's not in the list. Okay? So that's the idea with a rational zeros theorem. We're narrowing down what might be possible for rational zeros.